Hi class, Norman Stevens here. I want to go over the checkpoint problems and answers for Chapter 5 on elasticity. So let's begin. When the price of home heating oil increased by 20%, the quantity demanded decreased by 2%, and the quantity of wool sweaters demanded increased by 10%. The first question asks, use the total revenue test to determine whether the demand for home heating oil is elastic or inelastic. You know intuitively that when the price of home heating oil increased by 20%, the total revenue collected by sellers of home heating oil increased because the quantity demanded decreased by only 2%. Because the total revenue increased when the price rose, the total revenue test tells us that the demand for home heating oil is inelastic. But if you want to check, which I always like, that's good, calculate the elasticity of demand. So take 2% divided by 20% and get 0.1. As page 116 of your textbook states, if the price elasticity of demand is less than 1, demand is inelastic. Recall that when calculating the price elasticity of demand, we use absolute values and ignore the minus sign from the decrease in demand. Question 2. If the price of a wool sweater did not change, calculate the cross elasticity of demand for wool sweaters with respect to the price of home heating oil. Are home heating oil and wool sweaters substitutes or complements? Why? The formula for the cross elasticity of demand for wool sweaters with respect to home heating oil is, and here's the formula, the percentage change in quantity of sweaters demanded, and note please that it's the percentage change, not just the number of sweaters demanded, but the percentage change, divided by the percentage change in the price of heating oil, and that's 10% divided by 20%, or 0.5. So that's the cross elasticity of demand. Home heating oil and sweaters are substitutes because as the price of home heating oil rises, you can stay warm by using less home heating oil and putting on a sweater. The cross elasticity of demand for a substitute is positive. Question 3. The figure shows the demand for movie tickets. Is the demand for movie tickets elastic or inelastic over the price range $7 to $9 a ticket? If the price falls from $9 to $7 a ticket, explain how the total revenue from the sale of movie tickets will change. Calculate the price elasticity of demand for movie tickets when the price is $8 a ticket. Alright, so you use the information in the graph, and you're going to use the midpoint method as well to make these calculations. The percentage change in the quantity of movie tickets demanded equals, and then here's the formula, 300 tickets minus 100 tickets, that is noting the difference. And then in the denominator, 100 tickets plus 300 tickets divided by 2. And again, this denominator figure is due to using the midpoint method, trying to find the average number here. Times 100 for the entire quantity, and that'll get a number of 100%. The percentage change in the price of a movie ticket equals, and again a similar formula but now using the price of movie tickets, same methodology, and you should come up with 25%. So the demand for movie tickets is elastic because the percentage change in the quantity demanded is larger than the percentage change in price. That is 100% is larger than 25%. Because the demand is elastic, the fall in the price of a movie ticket increases the total revenue from the sale of movie tickets. When the price is $9 a ticket, the total revenue is $9 a ticket times 100 tickets, which is $900. That's the total revenue at that price and quantity. When the price is $7 a ticket, the total revenue is $7 a ticket times 300 tickets, which is $2,100. The difference between $2,100 and $900 is $1,200, and that's the increase in total revenue. For the price of $8 a ticket, the price elasticity of demand for movie tickets, same formula, is the percentage change in the quantity of movie tickets demanded divided by the percentage change in the price of a movie ticket. The percentage change in the quantity of movie tickets demanded equals, same formula, and you should come up with 40%. And then the percentage change in the price of a movie ticket should come up with 11.5%. So the price elasticity of demand for movie tickets at the price of $8 is 40% divided by 11.5% should give you 3.5. And it's actually 3.478, so rounding up gives you 3.5. Question 4. The price elasticity of demand for Pete's chocolate chip cookies is 1.5. Pete wants to increase his total revenue. Would you recommend that Pete raise or lower his price of cookies? Explain your answer. Because the price elasticity of demand for cookies is 1.5, Pete should lower the price of cookies to raise his total revenue. Because demand is elastic, a decrease in the price of cookies will bring about a larger percentage increase in the quantity demanded than the percentage fall in price. Some background information for question 5. The price of a plane ride rises by 10%. The price elasticity of demand for plane rides is 0.5, and the price elasticity of demand for train rides is 0.2. The cross elasticity of demand for train rides with respect to the price of a plane ride is 0.4. Question 5 states, calculate the percentage changes in the quantity demanded of plane rides and train rides. The percentage change in the quantity demanded of plane rides equals the price elasticity of demand for plane rides multiplied by the percentage change in the price of a plane ride. So it'll be 0.5 times 10%, gives you 5%. The percentage change in the quantity demanded of train rides equals the cross elasticity of demand for train rides with respect to the price of a plane ride multiplied by the percentage change in the price of a plane ride, which is 0.4 times 10%, a 4% increase. Question 6 asks, given the rise in the price of a plane ride, what percentage change in the price of a train ride will leave the quantity demanded of train rides unchanged? Well, from the previous answer, when the price of a plane ride rises 10%, the quantity of train rides demanded increases 4%. The price rise of a train ride necessary to decrease the quantity demanded by 4% is 20%, because a 20% increase in the price of a train ride decreases the quantity demanded by 0.2 times 20%, which is 4%. Question 7. A survey found that when incomes increased by 10%, the following changes in the quantities demanded occurred. Spring water up by 5%, sports drinks down by 2%, cruises up by 15%. Which demand is income elastic? Which is income elastic? Which are normal goods? So asking those 3 questions. Because the percentage change in the quantity of cruises demanded increased by more than the percentage change in income, the demand for cruises is income elastic. Because the percentage change in the quantity of spring water demanded increased by less than the percentage change in income, the demand for spring water is income inelastic. The demand for cruises increases with income, so cruises are a normal good. The demand for spring water increases with income, so it is a normal good. The demand for sports drinks decreases with income, so it is an inferior good. Background information for question 8. Headline reads, record U.S. corn crop up 24% is forecast. The USDA reported that world corn production will be 9.9% greater than last year's, while U.S. corn production will be 24% larger. The price of corn is expected to be 46% higher than last year's price. Question 8 asks, calculate the U.S. price elasticity of supply of corn. Is this supply elastic? The price elasticity of supply equals the percentage change in the quantity supplied divided by the percentage change in the price. Again, it's the same formula that you use for price elasticity of demand and for calculating cross elasticities, but for the price elasticity of supply, again, percentage change in the quantity supplied divided by the percentage change in price. The change in the U.S. quantity supplied is 24%, and the change in the price is 46%. So, for the United States, the price elasticity of supply equals 24% divided by 46%, which is 0.5. The U.S. supply of corn is not elastic, it is inelastic. It's less than 1, so inelastic. And those are the checkpoint questions. I hope those questions are... Oh, sorry about that. Last two. Got carried away. Question 9. Calculate the world price elasticity of supply of corn. The price elasticity of supply equals the percentage change in the quantity supplied divided by the percentage change in the price. The change in the world quantity supplied is 9.9%, and the change in price is 46%. So for the world price elasticity of supply, that would equal 9.9% divided by 46%, which is 0.2. Question 10. In May 2011, higher food prices forced consumers to cut spending. Question asks, is the demand for food elastic or inelastic? Explain your answer. Because spending on other items decreases, expenditure on food increases. The total revenue test shows that if expenditure on an item increases when its price rises, then the demand for the item is inelastic. The demand for food is inelastic because expenditure on food increased when its price rose. Written another way, food is a necessity with few good substitutes, so its demand is inelastic. And this question might cause some questions, such as there are food substitutes, such as switching fruit in terms of apples versus oranges, or for meat versus fish or tofu. But the fact is, if food as a whole increased, the price for food increased, people still have to buy the food because people still have to eat. So demand is inelastic. And that is the last question. If you have any questions about any of these questions, please send me an email, ask, be happy to explain. Thanks very much.